Integral from minus infinity to plus infinity e to the power negative x square dx is equal to square root of pi. We use this formula in engineering and physics many times. Now we are going to show that how this integration can be calculated. Let I is equal to the integral from minus infinity to plus infinity e to the power negative x square dx. Okay, so if we change the variable, this should also give us the result I, minus infinity to plus infinity e to the power negative y square dy. Okay, so we can write I square the integration negative for x is equal to negative infinity to positive infinity into the power negative x square dx times integral from y is equal to negative infinity to positive infinity e to the power negative y square dy. We can write so x is equal to negative infinity to positive infinity, y is equal to negative infinity to positive infinity e to the power negative x square plus y square and dx dy. As we can see, in this axis we are covering dx dy would be like this area element. This is our dx, this is our dy. So the area element is dx dy. If we change our variable or to in polar coordinates, okay, but in polar coordinate system, for a small angle d theta we can consider this small square. So the small square would have area of dA. This length is dr and this length would be r d theta. So our area is r dr d theta. Now what about the limit? We can see x covers minus infinity to plus infinity, y covers similarly minus infinity to plus infinity. So we have to integrate over the entire 2D plane, xy plane. So how can we cover the entire xy plane in polar coordinates? If we consider r 0 to positive infinity, because r cannot be negative in this case, and theta is 2 pi, we can cover theta 0 to 2 pi. So r 0 from 0 to infinity, theta from 0 to 2 pi. In this way, we can cover the entire 2D plane. Integration was x negative infinity to positive infinity, x y negative infinity to positive infinity, e to the power negative x square plus y square dx dy. In polar, we can write this as e to the power negative r square, because in xy plane the r square can be written as x square plus y square from the Pythagorean theorem. So we can write r dr d theta. So our r is from 0 to infinity and theta is from 0 to 2 pi. We can integrate for theta separately, theta 0 to 2 pi times r is equal to 0 to infinity e to the power negative r square r dr. Okay. How we are going to evaluate r0 to infinity e to the power negative r square r dr. Let r square is equal to z. So 2r dr dz. R dr dz over 2. We do the negative z dz over 2. So we have 1 over 2 minus e to the power negative z, where r is equal to 0 to infinity. So half e to the power negative e to the power r square r 0 to infinity. So from the previous calculation, we have this expression. Here we can write 2 pi 1 over 2 minus e to the power negative r square r0 to infinity. So pi minus limit r tends to infinity e to the negative r square minus 1 which is just pi minus 0 minus 1 we have I squared is equal to pi, so we can write I is square root of pi. So we just showed that integral from negative infinity to positive infinity e to the negative x square dx is equal to square root of pi. If you like this video, subscribe. If you have any question, comment below. See you next time.